Okay, I'm gonna remake the video. So I'm gonna get rid of all what I did and redo it. Okay, maybe I keep this. I'll keep the start part. I'll keep the starting part. No, sorry, I'll keep that part. But everything else I'll remove. Wait, wait 1 second. Okay, let me delete that. Okay, there you go. So let's hope my volume is working this time. Okay, it's working. So basically, what this question is asking is this question is asking that adding a certain number of moles of barium chloride to a certain number of moles of sodium sulfate, and that's going to give you a precipitation reaction. Now, if we write the reaction down, so you have barium chloride plus sodium sulfate to give you barium sulfate solid as you precipitate, and your NaCl. Now, the question asks us find the concentration of each ion in the filtrate. What is the filtrate? Basically, when you have sorry, I think red pen's better. Okay, basically, you have when you put you form this precipitate basically into the solution, and then what you do is you pour the solution down through the filter paper, and you appropriate apparatus. It's gonna give you the solid is going to get trapped in here, and everything else is going to be the filtrate. Everything else is going to be filtrate, which is going to be your NaCl, so your sodium chloride, and because barium sulfate exists in equilibrium as a solid, it would be some of your barium and some of your sulfate ions. Essentially, firstly, you do the easy bits, which is finding sodium and chloride ions. Um, so what you do is first you do limiting limiting excess, where you use C equals N over V, which is I rearranged to N equals C over V here for both of the reactants. So this is sodium sulfate, and this one right here is barium chloride. That's going to give you this amount of moles of barium chloride and this amount of moles of sodium sulfate. And a lot of comparison allows us to see that there's a limiting amount of uh, barium chloride moles. So we know that barium chloride is limiting. Now, how do we find the moles of sodium? We do moles of sodium. Sorry, how do you find the concentration of sodium and chloride? So, firstly, you just find the moles because concentration equals number of moles of volume. So you gotta find moles of sodium because we don't know that yet. So number of moles of sodium is equal to 2 times number of moles of because right 2 times the number of moles of sodium sulfate, and that's because there's a two is to one ratio of the whole molecule and sodium. Similarly for chloride, because it's barium chloride 2. There are barium chloride 2. There's 2 chlorine for every 1 molecule of barium. So that's going to give you, and evaluating this, you get 0.012 moles of your sodium, and you're going to get 0.00004 moles of your barium chloride. Now you need to find the concentration. And how do you find the concentration? Well, you take these and you're going to divide it by 0.05 for both of them. Why is it 0.05? That's because that's 50 ml. What happens when you add both of them is you're adding a volume of this, a volume of this. When you add them, the volume is going to stack up because you have some of this solution and then you're adding another solution. You're adding them together into one solution and then you're pouring it here. So when you add them to another solution, 30 plus 20 is going to give you 50 more water. And that's why you have to divide by 50 now because it's in a new solution and the concentration is diluted now. And that's going to give you your answer. So your answer is going to be 0.012 or 0.05, and it's going to be 0.00004 or 0.05. So it's going to give you your concentrations for your NaNCl. Okay, now for the barium chloride. For your barium chloride, because you got to find out its Ksp first. Now its Ksp is 1.08 times 10 to the negative 10. Your barium, so that's where your Ksp is. Let me just move down here actually. So you know your Ksp is 1.08 times 10 to the negative 10. Now, how do I know this? I have a chemical data sheet that tells you. I think you definitely need the KSP, and the question should give it to you. Otherwise, you can't do the question. So what you do is your KSP is this, right? Now your barium sulfate solid it exists in equilibrium with barium ions and sulfate ions, right? Equilibrium. So in your solution, you're gonna have the end. You'll have NaNCl, right? Na and then Cl in it, but you also have barium. You also have sulfate ions, but you'll also have some solid precipitate caused by this solid right here, and you have microscopic movement with macroscopic constancy. So it'll be a dynamic equilibrium um, between these guys right here. These guys right here. So you have some of this and some of these, some of this, some of this, and some of this. You have to figure out how much you're gonna have of each, or at least these guys anions. So what you do is you already know how much barium and sulfate you have before they've precipitated, right? So before they precipitate, you already know. Uh, Similar to the way you found sodium and chloride, this is going to be 0.000. This is limiting. What is it? Barium chloride is limiting. So this is a 0.0002 on 0.05, and this one 0.006 on 0.05. This is going to be your respective concentration of number of moles. Wait, yeah. Respective concentrations of your anion. Sorry, not your anions. Your ions. This is the anion. This is the cation. Sorry. Yep. So that's going to be your respective concentrations of your ions. Now, some of them, when you add them, it's going to precipitate, and you don't know how much of that's going to precipitate into a solid. So, what you're going to do is a common ion effect in reverse, or at least a common ion effect to find how much of the ions actually exist normally. It's not hard to say. Okay, now, so uh, basically, what you do is you assume. So you have this thing, right? This beaker right here. Oh, let me just. So you have this beaker right here, and let's ignore the NaNCl. You have some of the solid. So in normal common ion effect question, you basically what you do is you introduce some of the solid in. So you introduce BaSO4 in into this solution, and the solid, due to being slightly soluble, is gonna dissolve a bit to produce Ba2 plus and some SO4 2 minus. And how you solve this is another video. But basically, what would happen is that at the start, you'll have zero of this, and you'll have zero of this, of these two respective ions, barium and zero of sulfate. What's going to happen? Because you add the sulfate, because equilibrium is going to shift due to the Chateliers, plus x and plus x, right, into the concentration. And what you have here, you have a minus x, or as ghosting x. So you have x squared on 1 because it's solid is on count in the equilibrium. And then you have 1.08 times 10 to the negative 10, giving you your x value, which is how much of each ion is present. Now, in this case, what we have here is that you're adding ions instead of having a precipitate, right? You're adding ions. It's the other way. You're adding ions. You're trying to form a precipitate. We don't know how much precipitate is going to form, and um, you don't know how much precipitate is going to form. How much of each ion is going to get used up. A similar way to do this question in the scenario is you assume SO4 2 minus. There's SO4 2 minus already in the solution. Because why can you do this? Because you can establish that BaCl2 is limiting. Right? So as Na2SO4 or sodium sulfate is excess. Sodium sulfate is excess. So therefore, in ignoring sodium and chloride, you'll have excess SO4 2 minus ions, and you'll have excess SO4 2 minus ions, and then you assume that you have excess SO4 2 minus ions, and to that you add a barium sulfate solid. So when you add it, the solid, some of this solid is going to turn into Ba2 plus, and some is going to turn to SO4 2 minus. However, because there's SO4 2 minus already present, it's not going to be as much as it would have been in this scenario right here, because you have SO4 2 minus already has a concentration present here. So basically, you'll have BaSO4 solid that's right in the other video. Is you ignore this and you can just try I stable because so you have zero of this because it's limiting, and this right here, or sulfate right here, you can get its amount by doing its number of moles minus the moles that's used up reacting barium into a solid on that concentration. Now, cause there's zero, but Lashal's principle, when you add the barium sulfate solid, it's still gonna produce X. It's not gonna be minus X because there's zero of this here. So it'll be still X, but this value is gonna be lower. When you have this at the end, I'm pretty sure this when I evaluated this in the previous video, it was 0.1196. So this goes here. This whole thing is 0.1196. So there you go. Is not equal to your KSP, which is 1.08 times 10 to the negative 10. So you can use assume small x, and you can get rid of this x, and you get x times 0.1196 equals to 1.09 times 10 to the 10 negative 10. So you get x equals to 9. So then you divide this, chucking this here, and then let me just evaluate it for you. You will get 9.03 times 10 to the negative 10 for x. Now, what is x? X is the concentration of barium. So now you know the concentration of barium is x. And you already know what x is. And for sulfate, it's x, but don't forget it's plus 0.1196, right? And so that's how you find the concentration of all the ions. Yeah, I hope that helps. Dun, dun, dun.